Hi, everyone. I'm Sherry Herron, the GLOBE Partner and Mentor Trainer at the University of Southern Mississippi. And before that, I was at the University of Texas at Dallas. But before that, I was at BSCS, Biological Sciences Curriculum Study. BSCS founded the guided inquiry learning cycle called the 5Es, based on research for effective teaching and learning. At BSCS, I had the honor of being the lead author of a curriculum module for high school and college students titled Bioinformatics and the Human Genome Project. It was funded by the U.S. Department of Energy. Imagine that. Naturally, I used the 5E format. As a former secondary science teacher, I had always included field and laboratory investigations. And then as a university biology lab director and instructor, I ended up writing 4 different lab manuals for different courses using that format. It just made absolute common sense to me. First, you engage your students, then you explore the concepts through a common learning experience, explain the findings and scientific terminology, and then elaborate by integrating the knowledge to personal experience or a related topic, and of course, then evaluate student learning, preferably with a performance-based assessment, which is exactly what the SRS is all about. Of course, assessments can and should be used throughout the 5E cycle. I rely on this framework when developing a 10-minute presentation, a 1-hour lesson, or a 2-week unit. It can be scaled up and down and subscales all along the way. For this water cooler, my former doc student, Layla Ali, and I draw upon a lesson that we taught at a summer STEM camp for upper elementary students called Cosmic Quest. And we will soon host a teacher workshop based on our portion of the camp. So naturally, we begin our cosmic quest with viewing Earth from space. So I believe that Haley is going to bring up the lesson plan, and I'll let you just peruse the front material, the relevant science standards, or physical and Earth, the summary of the training. You can scan that. A moment. And then on the screen, we bring up the amazing picture of planet Earth. The photo that was taken in 1972 that just blew our minds. I was a senior in high school, and it just is amazing to me how it impacted my life and my career. And here I am 53 years later using it as the first engage for this Cosmic Quest lesson. Of course, an engage is supposed to be piquing the student's interest, drawing on students' prior knowledge. Viewing Earth from space involves beach balls, rockets, and satellites. So, Haley, I have updated this and have more information on the 5Es in the updated version. So, when you put on the link, let's make sure it's the latest edition, okay? Can y'all remember how revolutionary this picture was? Can we go back to it? I must say this, and Jody and Jen and Haley and all of the rest of you, you will not believe what happened to me this weekend. I was in Houston, Texas, and my fourth grade niece, great niece, asked me if I knew science because she had heard that I did. And I said, of course. And she said, well, do you believe the earth is a sphere or flat? Well, I was dumbfounded that she would be asking me this. And I said, well, honey, it's a sphere. And fortunately, on my iPhone, I have the astronomy background and it is beautiful. It shows the earth in real time. And I was showing her that and we were talking about it. And she said, but can you flip it over and see the backside of it? Can you imagine that? And I said, no, but I can turn it slowly so you can see all of it. And you can see from all the way around the equator. And then you can see all the way around the poles. And she said, well, that's what I thought. So in other words, we still need to do what we do. It's, I guess it's more important than ever. Who knows? Okay, so then I show them, go down and we look at this picture. And I said, now this is like seeing a sunrise or a moonrise or a sunset. And here we see Earth rising from where? And students, the kids immediately said, that's from the moon. And I said, yes. And then we, of course, tried to tease out what we're seeing with the clouds and Africa and Saudi Arabia and all that on the first picture. And then I follow up, well, why is the Earth called the blue marble? Or why was it called the blue marble when we first saw these pictures of Earth? And then scroll down, we bring out the big Earth ball that's on Earth balloon. It's only $21, and we do the throw and catch and count where your thumbs land and tally them on the board, and then with a young audience, it's pretty obvious that the water covers like 3/4 or so than the land does. And on this activity, I said, now, what would, if it lands on clouds, what would we call that? And there is, that's leading them into focusing on what exactly composes clouds and so forth. And we call that water. And then that ties into the states of matter and so forth. Then we go down to the explore. We had young ones, so we did a little coloring page here, and they could color. They could use whatever they decided would be water or land and the sun and the moon and the satellite. And but I asked, we don't have men or women on the moon anymore, so how are we going to see Earth from the sky these days? And that's what led us into satellites. And some brought up the fact that satellites are going way outside of the solar system, and we talked about those that just orbit the Earth. But at this link, there are 15 different printable sheets that show the Earth with a satellite above. We talked about the parts of the satellite briefly here. Then we go to these interactive websites that are phenomenal. Haley, are you going to be able to click on this first one? Yeah.
Okay. You can see what it.
Aqua. Okay. And you can see that you can rotate it. And talk about the parts and so forth. And then we will, I'll call on somebody to manipulate another one. Then we'll go to Eyes on the Earth. This is an amazing website. And you can manipulate the whole planet. And you can manipulate, you can zoom in on one particular satellite. Isn't this amazing? And watch how it's working and so forth. And at the bottom, you can ask, you can see all of the data that's collected by the various satellites, sea level, precipitation, carbon monoxide, water vapor, water storage, on and on and on. So this is, and I love this one. You can see the how the orbits take in data from swaths of land. And this is from September 8th, 2028, sea surface temperature. And we talked about colors, what they mean, and so forth. Any way to put the link to the satellites?
Yeah, John, after the water cooler, I can, Sherry, if you're okay with me sharing your document.
Oh, absolutely.
And I'll get the updated version from Sherry and we can share it out and it has all the links in it if that works. Yeah.
Right. And then we go to a NOAA link, because this short video also explains the various kinds of orbits, geostationary satellites, and those that aren't. So if you wanted to press just a little bit of that.
NOAA operates 3 types of satellite systems for the United States. NOAA operates 3 types of satellite systems for the United States: polar orbiting satellites, geostationary satellites, and a deep space satellite. Polar orbiting satellites circle the Earth and provide global information from 540 miles above the surface. Geostationary satellites constantly monitor the Western Hemisphere from 22,240 miles above the Earth. And our deep space satellite orbits 1 million miles from Earth, providing space weather alerts and forecasts, while also monitoring the amount of solar energy absorbed by Earth every day.
That's enough. Thank you. So I thought that was quite succinct and clarifying. So then I ask, well, how do satellites get into space? And I was curious about that because, we grew up watching, or, we were growing up, or adults, when we were watching the rockets launch. That doesn't get as much coverage anymore, but these kids pretty much knew that rockets put the satellites into space. And then I held up a paper model of a rocket, and these things are hard to find now unless you spend a lot of money. And I said, well, is the satellite in the bottom of the rocket, the middle of the rocket, the top of the rocket? Where would that be? Haley, if we can go back to the document now. Oh, you're ready. Yeah. And so then we go to the SMAP launch and deployment sequence that I find is beautiful. for a number of reasons, and we watched that one. Lift off and the stages. And then I love this one because it shows it, it's more like a robotic thing, a transformer kind of thing that the kids love to play with. And the solar panels. Soil moisture, active, passive, but that wasn't as important to say the whole name for them. The computers turning on and making contact, and the engineers on the ground, computer scientist, robotic arm. And then I love this, for it to come out like an umbrella almost. And well, it does. Solar panels facing the sun. I mean, if that doesn't light some imagination for engineering, I don't know what would. And now the antenna starts to spin. And the satellite is orbiting the Earth. And there you go. You see how it is. Yes, MAP. Yes, soil moisture active passive. So this is really a nice one to show, I think. And then if your school has a 3D printer, you can actually let kids, I guess, make some rockets. I mean, rockets and satellites. And this is a one link I found. There are not that many actually. How to print use a 3D printer to print a satellite, and maybe the high school kids could do it, or the teacher could do it if they know, or whatever, how to build satellites. I found only one link to purchase satellite models, and then when it came time to order them, the link was gone. They were out of business, I guess. But 3D printing is the way to go. And now for the explain, I'm transitioning from satellite imagery to cloud data. Why does NASA want us to send cloud data to them and look at the clouds? And there's a wonderful video with Jessica Taylor that makes that information very clear, and we can watch a little bit of it. We don't have to watch all of it. I like this because it highlights the GLOBE program, presenting clouds.
GLOBE is a community of scientists, teachers, students, and citizens from more than 100 countries around the world. Their efforts in collecting information, or data, are helping us to better understand our environment. And now we need your help in collecting data so we can better understand the different types of clouds and the effects they have on Earth's climate. At any time, over 70% of the Earth is covered by clouds, and these clouds play a really important role in helping to control Earth's temperatures. For example, have you ever been outside on a hot and sunny day when a cloud rolls overhead and provides you with some much-needed shade? Did you notice that the temperature suddenly felt cooler? That's because these clouds are blocking some of the sun's heat from reaching the Earth's surface by reflecting that heat back into space. Clouds like these that help to cool the Earth's temperature are lower to the ground and thicker, like big puffy cumulus clouds or the thick flat stratus clouds. On the other hand, there are clouds that actually help warm the Earth. These clouds are high in the atmosphere and made up of tiny ice crystals and are usually really thin. Cirrus clouds are a type of high cloud, and they let most of the sun's energy pass right through them, reaching the Earth's surface. These
That's
clouds
enough,
also
Haley, I
help to
think.
absorb.
So yeah, others really like to use this particular video. And then I will ask them to find their questions that are taped to their seats. And these questions would be the quick facts about clouds on our website. What is a cloud? How do clouds form? And that sort of thing. And they find that on their phones or laptops and write it down. And I give them just a few minutes for that. It's not a long. And then I ask for this would be for the teachers. I didn't do this for the part for the kids, of course. And I ask a volunteer to read their answer. We don't have to do them all because they're all very redundant, right? And the same answers can be used for many of these questions. Then I go to another video. This one's from UCAR, the Center for Science Education. And this one by Lisa is a very good one to learn about the types of clouds, and for elementary students. You can click on just a little bit of that one.
Look, it's a cloud. But what type of cloud is it? Clouds are given different names depending on their shape and their height or altitude in the atmosphere. Low in the atmosphere, you'll find cumulus clouds. These grow vertically so they can become higher clouds over time. They look like floating cotton balls with sharp outlines.
So you get the point of how that one is perfect for elementary. And then we explore we go explaining more about clouds by using the cloud storybook. And I will have, the pop reading of where one reads and then names another teacher to read and so forth, so that we read this book together. And then we go to the discovery stations for each of the activities to use. And in fact, I may break it up, for them to experience the activity along with where we are in the book. So this would be like a cooking show. And I'll provide the list of materials. I think Jody's the one that told me about this page. Then the elaborate, go deeper. We're going to go outside and use this cloud viewer again from UCAR. We have another one that the sky window or whatever, but it's very complicated for elementary. It covers a lot of information. And this one I find um, is not as intense for elementary. Um, they loved going outside, the kids did, and I had to stress not to look at the sun, but I look at the sun every day. I said, well, don't do it anymore. You're damaging the retina in your eyes. Don't do that. um, but I have one of the things I inherited from um, Lynn Vaughn in Alabama, Amsti, was one of those wooden pieces of wood with north, south, east, west, and the flag and all that on it. And so I had set that up, and I wanted them to look in the 4 cardinal directions and up away from the sun, and they could pick, the picture that most aligns with what they're seeing, and they could see different ones in different views. And I also pointed out contrails, which is not on this picture, but we did discuss that. And one little girl lives near an airport, and was very interested in how these contrails are man-made clouds and would function in the same way and impact our weather. And then we'll go to the protocol e-training modules for them to see that and explore that. And there are the cloud tips and get the app and so forth from the actual GLOBE website. I believe that everybody probably has seen all of that, but if you haven't, explore it. It's great. And then my favorite workshop assessment is just a series of prompts. I expected, and you see they have limited space, so they don't have to feel like they have to write an essay. I got a thing of value, I wish, next I will. And then you can quickly go through these. If this is a multi-day workshop, you can make adjustments quickly. But if it's just this one day, you collate all the expected, all the GOTS, etc., and you can do a real assessment of how it went and what you need to change next time. So that's it in a nutshell. Questions? Thank you.
Hey Sherry, have you seen the Nube cards?
The what?
The Nube cards, the cloud. Oh, I don't have there's a deck of cards. There are a deck of
Oh yes, I signed up to do that, but I haven't done it yet. Yeah.
Oh, okay.
Or I
Yeah.
was gonna, yeah.
It's like an Uno game, but they're all about clouds, right? And
Oh,
I think
good.
there you go. Yeah,
There you go. Yeah.
it's great. It's actually good for all ages, even though you think high school kids don't want to do that stuff. But you
I've
can,
ordered them. Yes, I've ordered them.
yeah, you can you can really kind of modify the game. Like for high school kids, I say, okay, well, you're not allowed to put the same kind of card that has the same sky color or cloud, but you have to call out higher or lower in terms of clouds. That means the next card the kids have to know that cirrus is higher than alto kind of thing, right? So it's just kind of a nice, it's a nice cloud activity edition.
Can you print them off yourself? I mean, I've ordered them, but
Yeah, you
you
can.
can? Okay. I'll do that before the workshop. Thank you.
Any other questions or comments? Kristen, I feel like there's a couple people that have, and Tracy, there's a couple of people that have done modifications. I know John, you're on mute, Kristen, or I can't. Maybe you're not on mute, but we can't hear you.
It's because it switched to the wrong, like it switched off the webcam microphone, and I don't know why. But yeah, it would be great to collect some of these adjustments that people are doing, and we could add those to the Nube instructions page, because I think that's always helpful to give people ideas about how you can adapt it. And yes, you can print it yourself, Sherry. So there are files specifically for that, and Heather Mortimer, who did the graphic design for that, and I tested and made some tweaks to try to make sure that they print. I'm not going to say completely foolproof based on your printer, but as best as we could manage.
Great.
And I was going to say, I found, so here's my little 3D printed GPM. Although I think my antenna broke off on this one. I never posted this anywhere, and it's a little bit rough. But if anybody wants this file, I'm happy to send it to you. It prints in like multiple pieces, so it all prints flat, and then you fit it together. So that was fun when I was working on GPM before I was on Globe.
That's great.
Well, and I actually developed, there's also the Lego model of GPM that is on the GPM website, that one of the other fun things I got to do when I was working for GPM was put together the instructions for how to make I didn't develop the model. That was a high school robotics club from West Virginia, but I did do the instructions for how to put it together. And that's on the GPM precipitation education website.
GPM.
A few other satellites have Lego models too, but yeah.
Lego GPM.
Yep, Haley put it in the chat there.
Yeah.
And we will make sure that we send out the links to everything after words and post this. So
great.
Any other questions or comments?
I was just going to comment that I didn't know you worked for BSCS, or maybe I heard that, but I forgot that. And so I love the 5E model spin on this whole thing. I can't do anything without thinking of the 5E. That's just the way my brain works now, you know. So this is so nice because it just comes together as such a nice unit. And, you know, more than just a one and done. So I really appreciate the fact that you took the time to put that all together and make this nice package that teachers can use. So I'm looking forward to share it. So I will share it with far and wide in Ohio.
Well, I consider that a great compliment.